Hello everyone and welcome back to Skilling Minds. If you're new to my channel, please do subscribe with the bell notification so that you're the first one to receive our videos. And today we are here with another hands-on session on bivariate analysis. Bivariate analysis is one of the simplest forms of quantitative analysis. It involves the analysis of two variables for the purpose of determining the empirical relationships between them. Bivariate analysis can be helpful in testing simple hypotheses of association. So, let's begin.
Welcome to Skilling Minds, where we impart skill knowledge with easy to understand presentations and hands on sessions. So, whether you're a student or a corporate professional or a homemaker or an entrepreneur, adding skills helps you to increase productivity and attain proficiency. Most people delay adding new skills either due to lack of time or resources. But here at Skilling Minds, we will enable you to learn new skills at your own pace that can help you to stay ahead in today's competitive world. So let's jump straight away into today's topic and add a new skill to our portfolio with Skilling Minds. Welcome to hands-on session on EDA Bivariate analysis. Let's start by renaming our worksheet with bivariate analysis. Now you would have already looked in my previous videos how I imported the requisite libraries, so I'm not gonna go through them again, but I'm just gonna run them so that we have them with us, and we should be able to continue with our bivariate analysis. So in the similar way with how we did last time, I have pulled in the important libraries that we would require in Python to do bivariate analysis. Now I'm going to run a command where I should be able to pull the data. And now let's look at the head of the data. So just a quick check, the file has uploaded properly. I can see a lot of columns and a lot of data already showing to us, nothing missing out. So all this is great. Now let's proceed to put in the command to look into bivariate analysis. Now by the word bivariate, I'm sure you would have already guessed that we are going to look into relationship between two variables. Now all the columns that we have here, which could be a quantity ordered, a price each, sales, all the numeric columns that we have here. Let's see if we can kind of put a plot or chart to see if we can see if there is some relationship between them, or rather let's say, do we have any correlations between these two variables. So there are two ways we can do that. The first one is to pull in a heat map. So we're going to put it from Seaborn, so sns.heatmap. Then we're going to give the name of our file, which is df, and then we're going to put corr for correlation, and then we're going to put anot equals to true. I'll let you know what annotation stands for, and how it works after finishing the command. Then definitely it has to be plt.show, and then you close columns there. Let's see what it pulls. So it pulls up something like this, which is a heat map. On the left hand side you see the variables that we have pulled from the data, and the same variables are also available on the lower end. However, what we need to look is one-to-one relationship between each of this variable with the other variables that are available in the data. Also note that only numerical values which are there in any of the variable is pulled, and anything that was into categorical, something like we have product line like motorcycles, or status like shipped, will not be pulled in this kind of a heat map, because it's going to only tell us the relationship between numerical variables. Also, I mentioned about the annotation true. So let me just do this to show you that what if I remove this, if I don't use this in the command, what will happen? So if I use it without it, you see there are no values available inside each of the boxes here. And that's the reason this is a very important command to put annot equals to true, so that we are able to pull in all the values which are available for correlation. Now, once we go through this data, we have to look at this bar on the right hand side. And if you see, starting from minus 0.4, minus 0.2 to 0 to positive 0.2, 0.4, and up till 1. You also see the colors change. It is much darker when it is around minus 0.4. Relatively gets lighter when we reach around positive 0.4, and then towards the up when it's one relationship, it really gets the lightest. So from darkest to lightest, this is how it is. And the same way you would understand the relationship also. So anything that's been given a score of around a negative 0.4 has the weakest of the relationship, and anything which has 1.0, positive 1.0, has the strongest of the relationship. Now, how do we read this? Let's look at variable by variable. Of course, order number is just a number like an employee ID, so it will not kind of make any relationship with any of the other matrices that we have or any other variables that we have. Let's jump to the next variable, which is quantity ordered. And as we progress, looking into the relationship with each and every other matrix that we have, for example, with price each, it's around 0.01, so it's a very, very weak relationship. Then it's even having a negative relationship, again with the order line number, because it doesn't make any contribution or any participation or correlation values that we can really call out. But when we progressed further, like on to the fifth box, which represents sales, so sales and quantity ordered looks like there is some relationship. The color itself is on the lighter side, and the value attributed to it is around 0.55, which kind of indicates some kind of a medium or a moderate relationship that is there between these two matrices. So on the face value of it, something looks like if the quantity ordered goes up, the sales value also goes up. If the quantity ordered goes down, the sales value would also go down. So it looks like that those kind of the relationships there. When we move further, let's see for price each. Interestingly, we see something of a very lighter note color here, which is of 0.81, and anything between 0.8 to 1 is the strongest of the relationships that we have. So price each is directly proportional to sales, and again it goes with the same preposition that if price each increases, sales increases. If prices decreases, sales decreases, and the same goes up with MSRP also, which could be the maximum sales point that you would have a price point to sell each of the items. So price each is very, very strongly related to MSRP. So in this way, we look at the positives and the negative relationship between two variables in this set of bivariate analysis. Another way of looking into relationships between two variables to come out with bivariate analysis, we can pull a pair plot. Now, what does the pair plot do? I'll just show it to you. So let me put in the command SNS dot pair plot. tf is the name of our file, and then we'll put plt.show so that we are able to display the graph. Now this usually takes a bit more time than what heat maps take because it is much more elaborate. Now let's see what the results have come. So you will see a lot of graphs that's been pulled out, and each graph shows relationship between one variable to the other. And in similar way to the heat map, on the left hand side you will see all the variables listed, and also on the lower end you will see all the other variables related could be seen. And what we have to really look forward is to see some kind of a trend that could tell us about how weak or how strong the relationship is there between two matrices. So when we go through this data, we see a lot of data has been stacked together. It doesn't make any kind of a trend analysis. It's not like an upward or a downward movement. It looks quite static, quite there into the phase. When you come to quantity ordered, and let us move up to our previous example of the fifth flocks, where we saw a relationship between quantity ordered as well as sales. We can see some of the data movement here. It starts from a very lower point, then it kind of increases all the way up, and it's kind of going in a trend which could show upwards. It could be one of the indicator that there is a relationship which is directly proportional between these two matrices. Also, when we look at price each and we look at sales, again you see the trend going upwards. This is a very different kind of data point being stacked up together, least at one point when it start beginning, but as the price increases, you can also see the price is also increases. Very similar to the way we have seen for price each and sales, which was here at around 0.81. You could see something of the same happening with price each and sales on the fifth block, where it's kind of trending upwards. And then there are each and every chart where you can look into, draw your analysis, make your own conclusions, and have a look into how these two variables are attributed to each other in kind of display, not through numbers but by visual presentation of looking at trends from these data points. So anytime when you want to analyze two variables for a bivariate analysis and want to represent it through charts and not numbers, then pair plot is one of the best one to do that. However, if you want to do a numerical representation of the correlation between two variables for a bivariate analysis, you can always go for heat map. With this, I would like to conclude today's hands-on session on EDA bivariate analysis.
If you like this video, then please go ahead and give us a thumbs up. Don't forget to subscribe Skilling Minds. Leave us a comment on which skill video would you like to watch next. Also, press the bell notification button so that you're informed as soon as we upload a new skill video. Till then, take care and bye.